Welcome. Thank you for visiting. My name is Rick Diamond, owner of Airport Planning and Management, LLC. I started the business to provide the same type of services I've been providing through my 40-year aviation career. 10 years managing a small commercial service airport, 29 years as an airport planning consultant, and a couple of aviation jobs before that. Today, I wanted to offer you two services which I really could have used when I was managing the airport: improved wind coverage analysis and new weather coverage analysis. This is the format of most of the wind analysis software. The data that I'm going to be using is for the airport that I used to manage. Here, with the FAA Windrows program, 124,950 observations are average summarized into tens of degrees and 3 to 6 knots here. So 124,950 observations are summarized into 325 data points, which are used to calculate wind coverage. As you can see from this summary, detailed information such as date, time, sky condition, weather condition is not available. Are there any data points missing? Are there certain months or times of the day where there are more observations than others? That isn't available with this summary data shown here. With the typical process is these average points are then grouped into a Windrows mathematically or geometrically that looks like this. And then what's shown are the crosswind components here of 10.5 as shown. The areas are estimated here. Another point is it's fairly difficult to discern the characteristics of the wind relative to the runway orientation. Plus, you'd have to figure out what these pluses are, which are less than 0.1%. This is the information I use. It's available from the National Climatic Data Center for anywhere in the US. It's available from Iowa State University College of Agriculture for pretty much anywhere in the world. I'm sure there are many, many sources of this information other than these two. What's also shown: time, hourly weather type, light, snow, haze, up to 3 levels of sky conditions, visibility, again the winds, as well as that same information in MEDAR format common across the world. The way I use this data for wind coverage, and I'll discuss weather coverage shortly, is I calculate the crosswind component for each and every observation for each and every runway end. The airport I used to manage, 2 runways, 4 runway ends. There are 500,000 crosswind component calculations instantaneously, much more accurate. All of this detailed information, date, time, weather, sky conditions, stays with the process and it's available. This is the Windrows that I generate, a little bit different than what's typical. Wind speed groups can be in any group that's useful. The alignment of the runways, and what's shown is the wind speed, and then the farther from the center, the more frequent the observation. Obviously, the slower wind speeds are shown here have a higher frequency. What's shown in the middle, very hard to see, are the higher wind speeds. All I would do is rerun this Windrows, remove the low wind speeds, and then you have the detail on these higher winds. Back to here, you can see that this format is much, much easier to see the wind characteristics relative to the runway ends. If you'll notice here, very few wind observations in this quadrant. That may indicate close-in trees or maybe a hill off to the east. This be an excellent way to check up on your wind instruments, either the particular one at the airport or the wind instruments across your state. You could do an annual data gathering and plot an annual Windrows, see how they change year to year. Or a particular Windrows, if you were to remove obstructions, trees, or relocate the instrument, do the Windrows again, and this would give you that information. Here, with that same information for this particular airport, 371 observations, is found 11% were unusable. That means it was missing wind or weather data, or it was missing ceiling, sky cover, or visibility. As you can see, fairly stable, unusable observations, Then they decreased significantly between 2012 and 2014, possibly a replacement of the weather instrument here. FAA, ICAO, European Aviation Safety Agency, all agencies have some standards by which you're supposed to use wind, I'll say weather data. FAA says 10 years of consecutive weather data. ICAO, European Aviation say 5 years with the additional requirement of at least 8 observations per day. Preferably those 8 observations are distributed evenly throughout the day. Taking the same data that we just saw, match that today, 10 years, 3,640 days, it can be proven that every single day had at least 8 wind direction and wind speed observations. However, there were 182 days when there were at least 8 observations, including ceiling, sky cover, and visibility. To illustrate the benefit of using this detailed information throughout and the flexibility, I'll show you the data, 10 years of data by hour for ceiling, sky cover, and visibility. What's shown here, for some reason, there are more observations done in the time period between 10 o'clock at night and 9 o'clock in the morning. More critically, there are many more low ceiling observations, black and the red, in that same time period, 10 o'clock in the evening till 9 o'clock in the morning. Same curve for sky cover, broken, overcast, and obscured, yellow, blue, and the red. And for visibility, the low visibility being the gray, black, and the red. Same curve. What we just saw, ceiling, sky cover, and visibility generates the profile of VFR, IFR observation. 10 years, most VFR observations occur between February and July. Most IFR observations occur between July and October, plus December. Taking that same information, match it to the hour, you have the curve for IFR observations. And this curve is very similar to what we just saw for ceiling, sky cover, and visibility. This chart brings up a couple of important points. FAA, ICAO, and the other agencies all require that the data that you use be for the appropriate time period. For instance, if you were using a VFR runway, you wouldn't include IFR observations. If you were including a day, an unlit runway, only usable during the day, you wouldn't include nighttime observations. An illustration here, if you were analyzing the data when this tower is open at this particular airport, 6 in the morning till 10 o'clock at night, you wouldn't include the time from 10 o'clock to 6 o'clock in the morning. Not only is that a waste of time, it makes the data irrelevant and the recommendations less accurate. This shows wind coverage in the blue line, wind coverage for the runways at this particular airport, 725, 1836, 725, 1836 combined for 10.5, 13 knot, 16 knot crosswind coverage. Appears to be pretty good, between 95 and somewhat less than 100% all-weather wind coverage. But this red line is the new term I'm introducing in the new service called weather coverage. Weather coverage is wind coverage accommodated, you don't wind component, and the observations are at or above published approach minima. In other words, you can actually use the runway. Over 95% all-weather wind coverage, the amount of time when you can actually use the runways is down here at 72 to 80%. Quite a bit less. This is even more telling during IFR conditions. IFR conditions are typically low wind speed, so of course you'd have very high wind coverage. IFR is also low ceiling, high dense sky cover, low visibility. So the amount of time during IFR conditions, weather coverage, when the runways can actually be used, is down here at 22 to about 35%. That's a significant decrease. What can we do about it? With my system, it's very easy to do what ifs, to just replace the figures for the approach minima. Here, a 200-foot decrease in runway 36 minimum descent altitude, as well as a half-a-mile decrease in runway 25 visibility. Not much difference in 1836, but you can see a very slight increase in runway 725 weather coverage. This chart can be used one of three different ways. One, what you just saw, there's a particular procedure improvement to a particular runway end. How much more can this runway be used? Second, you may have a procedure in mind. Which runway would provide, with this procedure, would provide the greatest benefit? In other words, the greatest increase in weather coverage. And third, you may have a desire to improve the weather coverage up to 60%. Keep doing the what ifs until you get your curve up here to 60%. That would tell you precisely the amount of decrease in visibility and decrease in minimum descent altitude that you need to reach your goal. The same data we've been discussing in yet another format, daytime, nighttime by month, over 20 years of information. Daytime solid lines, nighttime dashed lines, runway 1836, blue, runway 725, orange. And what's shown during January, February, March, November, and December, the weather coverage, the time when the runways can actually be used, is basically the same. But as you move from March to August, September, and October, you can see that weather coverage during nighttime is significantly less than that during daytime. And this chart would indicate, ignoring the additional cost and the additional time required for nighttime construction, that if you were working on the runway or near the runway and you had to close the runway, you might consider closing the runway during nighttime when the weather coverage is low, and keeping it open during the daytime when the weather coverage is significantly higher. What's the benefit of detailed new weather analysis and weather coverage? Many reasons. You really need to understand the data. That detailed data stays with you throughout the process. All of the agencies require that you do it for the relevant, you do the analysis for the relevant time period, day, night, IFR, VFR, season. Wind coverage on a particular runway, and instead of just using the opposing ends of the runway, maybe you'd want to look at runway 18 and 25, runway 7 and 36. Precipitation conditions, if you have some low weather conditions, what's causing it? The detail would say maybe it's snow, maybe it's ground fault. Adding an instrument approach procedure to a currently VFR runway. More setbacks, more land control is required. Estimate what the approach minna would be. I would run that through my process, and that would tell you immediately what the theoretical benefit is before you do the TERPS analysis. Shutting down a runway during construction, we saw that with the day-night coverage. FAA Order 5138D Appendix G. It's absolutely critical that you understand what your wind and weather data is telling you, because your wind and weather coverage, you may have to justify your crosswind runway. By that I mean justify the existence of it so FAA will continue to financially support it. Check your wind instruments, your weather instruments out, either at your airport or the instruments across your state on a periodic basis. If you have an improvement in mind, match it up to a particular runway end and see the benefit. Rick Diamond, Airport Planning and Management, LLC. Contact information is to the left. Please view the website and see all of the experience-based aviation services I can provide. Today, I described two new services: improved wind coverage and new weather coverage. Both of these services I developed and now can provide to you. I only need two items of information to provide you these services: digital weather data and airport approach charts, both free and easily obtained. My analysis and the output can be totally adjusted to your needs. I can provide you these services directly to you, to your airports, or through your existing consultants. Thank you very much for visiting.